At 11:50, this video is going to just kind of put it all together, things that we've kind of you've received in like chunks and bits and pieces in previous videos. So I kind of find this to be an interesting example, kind of worthy of kind of thinking about. When we adopted our daughters from China, one of the first things we did is when we returned home, we took both of them to see their pediatrician. And one of the things that they were interested in was their head circumference. And it turns out that head circumference, based on the kid's height, can give you an indication of proper brain growth. It turns out that both of our kids, our children, are very, very, very bright. So we were very fortunate. But anyway, it's kind of, I guess, a personal reason why I kind of find this interesting data set to take a look at. So anyway, pediatrician wants to assess the relationship between a child's height and their head circumference. More specifically, the pediatrician would like to create a model that could be used to predict the head circumference. So guys, that tells me right then that this is my Y and this is my X. The rule of thumb there is whichever one comes first is always your X, the other is your Y. But in some situations, we have measurements that are collected at the same time. So there has to be a reason for the study, and that usually comes down to what the researcher wants to predict. So the pediatrician measured the height and head circumference of 7 kids from her practice and obtained the following results. So what variable is the dependent variable? That's going to be head circumference. Now report the descriptive statistics for both. Now back in the very first video or second video, I actually went through calculating each of these by hand, and I don't think that's too cool. I mean, well, actually, I do think it's kind of cool, but if I'm going to find these things, I want to find them as quickly and as efficiently as possible. So what I am going to do is I'm going to get out of this. I'm going to go to Stack Crunch, and I am going to start a new data set. Now, even though I'm given my head circumference first, because height is my X, I'm going to put it first. And then my head circumference, I'm going to put it second. So now I'm going to very carefully type these numbers. This is the worst part for me because it just is. I don't like it. So get these in as quickly and as efficiently as possible. Now, one thing you could do if we had a larger data set is you could copy and paste this into an Excel file and just save it on your desktop and access the file. That's one way of doing it. So head circumference, so we got 17.55, 17.05, 17.75, 17.35. I'll read it because it'll be easy for you to type. 17.65 and 17.55. Guys, if you're not done yet, pause me. Get these typed in. I'm going to go back over and make sure I got them entered in correctly. Nothing more frustrating than to miss a problem because you made a typo. It happened. I had a girl just last semester that absolutely bombed one of the questions. It was like a 20-point question on her midterm, and she had typed the information incorrectly. She missed a number. Instead of like 17.65, she typed in 71.65. She didn't go back and check her numbers, and she ended up getting a lot lower than what she really deserved. I went in and gave her some partial credit though. So, all right, gang, let's. I want to go. I want to exit full screen, and I want to exit that. All right, perfect. Okay, so the next thing we want to do is report the mean, median, standard deviation, and IQR. So, guys, you should know by now that we go to summary stats to columns. And I'm going to choose both of those. And then I want to come down. I want to do the mean. I want to do the standard deviation. What else do we have? We have the IQR. And we have the median, which is someplace up here, I'm sure. Yeah. So compute. And we see we have our values. So the mean height is 26.14. The median height is 26, and I'm going to be consistent. Round that to two places too. The standard deviation is 1.27. And the IQR is 2.75. All right, head circumference. Mean is 17.39. The median is 17.55. The standard deviation is 0.33. And the IQR is 0.60. Now, the kind of cool, kind of strange, I don't know, is when we look at this problem, our primary goal is to examine the relationship between height and head circumference. But the first thing we do is we concentrate solely on height and solely on head circumference and look at these as just one variable. So we look at them separately. But then we start in part C, we look at the primary goal of the study, and that's to examine the relationship. So what do we do first? Just as I've said before, we see it and we summarize it. We do a scatter plot. So my X is height, my Y is head circumference. I don't need anything special here. So I go compute. Do I have a linear relationship? Well, you know, it's not great, but it's not curved. So is the relationship linear? Yes. Next thing, is it positive or negative? Clearly it's positive. And next thing, is it strong, weak, or moderate? Now guys, this point right here, this kid that has a head circumference of 17.75, height of 25.5, if that kid wasn't included in this sample, this is a strong relationship, but this one kid right here is going to affect the correlation coefficient quite a bit, because you can see just a nice straight line there, but when this kid's in it, it's more this way. Now I'll tell you what we might do. We might take screenshots and look at the difference. We might take this kid out and look at the difference and see what happens there. So guys, I'm going to go with moderate. So a linear, positive, and moderate relationship. Now the beauty is, you know, we struggled a little bit whether this was strong or moderate. The beauty is, on the next page, we come in and calculate the correlation coefficient and the coefficient of determination. Well, guys, you should know by now that we can go to stat and go down to summary statistics and go to correlation. But the easiest way to do that is just go to regression, go to simple linear regression, and we're going to get a lot more stuff than we need, but we're going to get everything we need. So my X is height. My Y is head circumference. All this other stuff is kind of irrelevant. I would like the fitted line plot, and I would like to save the residuals. I'll explain that maybe in a future video. So gang, what have I got here? Again, I've got kind of tunnel vision on this part right here. So my correlation coefficient is 0.67. And my coefficient of determination is the R squared, which is 44.2%. Guys, remember from a previous video, I told you that the coefficient of determination, this r squared right here, is always reported as a percentage. So move your decimal place over 2 places and round to the 10th. So what does this tell us? Again, let's go back to that video that I gave you where I broke up this -1 to +1 into those segments. If you didn't watch it, you need to go rewatch it because I'm not going to repeat this. But this tells us that we have a moderate and positive relationship. So maybe not as strong as we would like, and I think that one kid is actually keeping this from being making it a moderate relationship and not as strong. But nevertheless, we have an adequate model here, an adequate relationship where we can explore the linear regression model that can be used to predict the head circumference from a kid's height for future subjects, okay, for future patients for this pediatrician. Now, the coefficient of determination r squared tells us that 44.2% of the variation in our y is explained by our regression model. It's kind of weird that you would explain something at this stage by something we haven't even created yet. But guys, right here we can create this regression model. And the answer is right there. So we would have that the head circumference predicted can be calculated by taking 12.87 plus 0.17 times the kid's height. Interpret in the context of the problem the slope as x, which in this case is height, increases 1 inch. The predicted head circumference increases because this is a positive. .17 inches. Makes this a little bit larger for you. Does the vertical intercept have a meaningful interpretation? Well, the vertical intercept definition or interpretation would be when height equals 0 inches, the predicted head circumference is 12.87 inches. The kid can't be 0 inches, so no, not a meaningful interpretation. Use your model to predict the head circumference of a child with with height 25.1 inches. So we can say that the head circumference predicted would be found by taking 12.87 plus 0.17 times their height. And guys, don't do something goofy and add these two numbers and multiply by 25.1. Please excuse my dear Aunt Sally says that we have to multiply before adding. You see a lot of stuff pop up on Facebook, or at least I do. So what we're going to do is we're going to take 0.17 times 25.1, and then we'll add to that 12.87. So the predicted head circumference for this kid would be about 17.2 2.2 inches. So what the pediatrician, the application of this problem could be that if the pediatrician has a kid that measures out at 25.1, and let's say their head circumference is only maybe 15. I mean, that's quite a bit. That's 2.2 inches below what we would have predicted it to be based on this model. So that could, and trust me, this is not my field, so I'm just kind of reaching here. That could indicate, could be an indication of slow brain development. I don't know. So it's not my field, but somebody who's that is their field, they could pair with a statistician and come up with some interesting stuff to make estimations and predictions. So guys, I hope this made sense. It's kind of tying everything together. The next video, I'll actually go in and work some problems on my stat lab. So I'm done. Have a good one.